I'll start this video with the SCRs. We already talked about SCRs in the previous video, so I'll brief on the SCR. So SCR is a 4-layer. We have PN. So it's a 4-layer, 3-terminal device. So there are 3 terminals: anode, cathode, and gate. All the thyristors are basically 3-terminal devices. Okay, so here it controls the current flowing. Current is going to flow through anode to cathode only in one direction. Current always flows from anode to cathode. It cannot flow from cathode to anode. Another important thing is, without triggering the gate voltage or gate current, you cannot, it cannot conduct current. Say for example, here is my input voltage. Okay, here is our input signal V. Sorry, this is a time t, and this is V. Okay, now whenever we trigger input value, that's where you're going to see the output. So say for example, I'm triggering my, here is the trigger. So triggering means I'm giving this input signal when at this time. Okay, that's the time. X-axis is the time. At that time I'm triggering the gate voltage, then it will act like a closed, and once it is triggered, then trigger voltage is no longer needed. Okay, so that's what. So whenever you see the input here, so negative half cycle, current cannot pass from, current cannot go through cathode to anode, so we don't see any negative half cycle. Again, for the positive half cycle, again I'm triggering right there, so here is my output. Okay, so you will see that's the output. So SCR gives you output in a controlled manner. So that's what SCR is. Now the next one is gate turn off thyristors. Okay, remember SCR cannot control once it is turned on. As long as anode voltage is higher than cathode, it will continue conducting. So the gate voltage cannot affect it. It cannot turn it off. Here the next thyristor is GTO, gate turn off thyristor. Unlike an SCR, you can turn on and turn off GTO by applying small gate current. Okay, so here we can turn it on as well as we can turn it off. This is a 5-layer PN. Okay, 3-terminal device. So to turn on, apply positive gate voltage, and to turn off, apply negative gate voltage. So as long as we apply negative gate voltage, it will be turned off. As long as we apply positive gate voltage, it will turn on. At the same time, we have to maintain anode voltage is higher than the cathode voltage. Okay, so here is a symbol. Some books follows this. So basically a diode symbol, and you saw this is SCR symbol. Okay, now this one is going to have one more arrow going upward. Okay, so that's the symbol for GTO. Now we can represent by using 2 transistors. You must have basic knowledge about the transistors. So transistor is nothing but a 3-terminal device. Okay, current always flows from common to emitter. So here is the collector and here is the emitter. So here this is supposed to be cathode, indicate with the K. Now current always flows from collector to emitter. That current can be controlled by using the base current. Okay, so here whenever I supply higher voltage at the anode, okay, you have to have the base value. So here is the trigger gate. So whenever I trigger positive voltage, it will act like a closed switch. Whenever it acts like a closed switch, there will be current is passing through this. Okay, and the IC1 current can pass through this too. Now whenever I give a negative value to this gate, automatically this junction is going to be act like an open switch. So whenever it is open, there won't be any current passing through this. So it's a very simple technology. Okay, so by using gate turn off thyristor, we can turn it on and turn it off by applying a gate voltage. So a GTO is a high performance electronic device. When we supply a positive pulse at gate, transistor 2 will start conducting and there will be current flow from anode to cathode. Okay, in anode to cathode. When we supply a negative pulse at gate, transistor 2 will go off, then the GTO will be in turn off mode. So I'm talking about this as a transistor 2. Now the next thyristor device is triac, triode for alternative current. Triac is a power electronic device where two SCRs connected back to back. Okay, so this one also allows current in both directions. Okay, now triac can conduct current in both directions. Here is the symbol for triac. So basically you are connecting two diodes in two SCRs in back to back mode. So we know that current always flows from anode to cathode. So here this is anode and cathode. Whenever for the positive half cycle, current will pass through the SCR1 as long as gate is triggered. So if we give the gate voltage, current is going to pass through the SCR1 in that direction. Now for the negative half cycle, current will pass through SCR2 as long as gate is triggered. So for the negative half cycle, current is going to go through SCR2 in this direction. Okay, so gates need to be triggered for every half cycle. So here we have to trigger the gate for every half cycle. This is triac. The next one is mass controlled thyristor. We call it as MCT. Mass is nothing but metal oxide semiconductor. Okay, mass controlled thyristor. It is a thyristor where two MOSFETs. MOSFET is nothing but it's a kind of transistor, metal oxide semiconductor field effect transistor. Okay, connected in back to back to an SCR. One MOSFET is useful to turn on the SCR and another MOSFET is useful to turn off the SCR. So this is another thyristor type mass controlled thyristor. Okay, so with this I'm done with thyristors. So far we saw almost 4 types. One is mass controlled thyristor, another one is triac, another one is gate turn off thyristor, another one is SCR. Okay, so I'll stop this video. Next video I will talk about BJTs, transistors. Thank you.